Good morning, good afternoon, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this video. Now, you'll hear a lot of background noise. It's because I'm at a school and basically learners make noise. Now, don't mind the noise. And so let's dive into the lesson now. All right, so for starters, we'll look at log properties. All right, so that is log properties. Okay, log properties. Okay. Logarithms are derived from index functions, and they help us evaluate values that we cannot simply evaluate if we were using direct indices. Okay, for instance, if we have 3x equals to maybe 7, okay? So if you're asked to find the value of x in this case, there is no way that you can raise 7 to some power, then we have a base 3 so that you equate the powers, okay? So, but logarithms help us simplify that, and we are well equipped with that. So let's look at a few log principles that we may put into consideration. So the first one is that if you have log of a times b, so these two are multiplying. So this is the same thing as log of a plus log of b. Okay, and maybe this is to base k. I'll put they have the same base k because it's not always that to be to base 10. So maybe if you have log to base k of a times b, you can simply separate the a and the b, or in other words, if you see logs that are adding and they have the same base there, they have the same base, simply you can combine them like that. The same applies for division. If you have a log base k and a is being divided by b, so this becomes log of a base k minus log of b base k. In other words, wherever you see logs of the same bases subtracting, you can simply simplify and bring them together like that. So this is division. Okay. The other principle or rule is the property of logs is that if you have log of base k, for instance, then let's say a is raised to some power b. Okay, so basically the b can drop. So this is one of the important rules. So the b can drop there and it becomes b log of sk. Okay, so any power applying to that, so the b can drop. So now here you have to be very careful because I would consider it as a misconception. Maybe if you have log to base k, then you have a b to the power n. Okay, so in this case, since the n is not applying to both of the a and the b, what you have to do is, first of all, you separate this. So see there, it's multiplication. So this can be written as log of a to base k plus log of b to the power n base k. So you need to pay attention on which side of the variable is the power being raised, because the entire variable there should have the power raised like that. So now this can be simplified as log base k of a plus the power drops, that is n log of b base k. Okay, so you should be very considerate on how you drop the power there. So that is just common misconception that you may fall into. All right, so let me just put up two more. All right, let's say you have log b to base k. Okay, now on your calculator, you are always calculating values of log to base 10, okay, of some number there. Okay, so if you want to punch on your calculator, so sometimes you want, if there is no number here, meaning that it's a log to base 10. Okay, so basically, for instance, log of 20. Okay, log of 20. If there is no number there, then it is base 10, and you can calculate it directly on your calculator. And now, if you have, let's say, log of 20 to base 5, this is a different, you cannot calculate it directly on your calculator. But a rule that I learned, or let me say it's also a derivation, but is something that will help you. You can convert any log to base 10 by simply saying the log of b to base 10 divided by the log of the base, so the log of k. Okay, and basically this is in base 10. So for instance, if you had log of 50 to base 2, so if you want to punch this directly on a calculator, you cannot, because a calculator only calculates for base 10. So to convert this to base 10, this is the same thing as log of 50 divided by log of 2. Okay, so this is in base 10, so you can punch that on your calculator directly, and it will give you the needful here. So the idea is this, okay, though I think it will go into what I'm trying to talk about. The idea here is that, let's say if you have k, I think I can prove this using the same thing I'm going to talk about. If you have k to the power n equals to b, okay, this is another log property, okay, that is, you can simply, if there is an equal sign there, okay, and this side there is no plus or minus or something like that, what you can do is you can simply introduce logs both sides. So that is log, then here it would be k to the power n, k to the power n equal to log, again equal to log, then b, okay, b, okay, like that. So simply, if you have two variables, let's say this is equals to that, you can introduce logs both sides, and basically this is what we'll be using for us to evaluate some log questions, okay, that asking us to evaluate the values of x and their likes. Okay, now in this case, remember the power rule, we can drop the power. So we can drop the power, this becomes n log k is equals to log of b. Okay, so now here you can make whichever variable you feel like making subject. If it's n, you can make n subject to the formula. Yeah, then I should also tell you how to convert, let's say I'll come back to this proof, but you should know this. I'll come back to it. You should also know how to convert a log to index form. Okay, so for instance, you have log of b to base k equal to n. How do you convert this to index form? So in index form, the base here becomes the base k, then this becomes the power n is equal to b. Okay, is equal to b. And basically here, I think here we can make, if we make n subject to the formula here, okay, which will prove this theorem here. Okay, I'll just prove it. But basically, that is how you can convert this to index form. Okay, this is how you can convert that to index form. Now, to the proof of this theory that I stated here, that said, if you have log b base k, this is the same thing as log of b over log of k in base 10. Okay, so now this is actually coming from the fact that if you have if you have k raised to the power n, okay, or let me start from here. Let me start from here. If you have log, log of b to base k equal to n, okay, this can be converted to index form as k to the power n is equal to b, and basically we can introduce logs both sides. So this will become log of k and log of that. So which will drop the power here. It becomes n log of k equals to log of b. Okay, and if we make n subject of a formula there, n becomes equal to log of b divided by log of k. Okay, we divide by log of k there. So we see that n is actually equal to this. Okay, so basically that's the proof for that. So that is how you can convert from base from any base of log to base 10. Okay, so you can just write the principles down, then we'll see how we can deal with the questions. So the first principle was just a summary here. So summary. Okay, so the first one that we had is that if you have log of a plus a times b, just here that log of ab to base k, so they are the same bases. So this is the same thing as log of a to the base k plus log of b to the base k. So even vice versa, it's true. You can start with this part, log of a to base k plus log of b to base k. This can be combined as that. So this was the first one. The second one that we had was if you have log of a divided by b to base k, okay, or we can start with the opposite. So if you have log of a base k minus log b base k. So since these are the same base and they are subtracting there, so this is equals to log. We pick the base, which is k. Then we start with the one that is on top here, the one we are subtracting from. So that would be a divided by b. So that was the rule there. Then we also talked about if we have log to base k of let's say b, okay, so we can change this to base 10 by simply saying this is a log of b over log of k. Okay, then we also talked about the power rule. So that is let me just write it here. So that is 4. So the power rule states that if you have log of a, then everything here is raised to some power n, and we have base k. So the base will be maintained, so the power will drop. So n log of a and the base k. Okay, so these are some properties that you should know. And we also talked about converting a log into index form. So if you have log of b to base k equals to n, how you convert this becomes the base. So you start with that one, k raised to the power n is equal to b. Then we also talked about how you can change this to logs. So how you can change that to logs is simply by introducing logs both sides. So that is log of k to the power n is equals to b log of b. okay, and we can drop the power. N becomes equal to log of k. Sorry, we drop the power. So we drop the power. So when we drop the power, let me just see. When we drop the power, we're going to have n log k is equal to log b, and simply n will be equals to log b over log k. Okay, and remember this can be written as log b then to base k. Hope you can see that. So this can be written as that. So which takes you back to what you had previously. So from here, let's look at some examples and see how we can work around them. All right. So for all of these questions, you are asked to find the value of x, except for question 2 that asks you to make y subject of a formula. So I'm going to do question 3, which is this one. Okay. All right, let me just change that to that. So I'm going to do question 3 and question 1, and you should be able to work out question B. Then I will give you more examples from there. So question B here simply asks you to express y in terms of x, so which is just simply making y subject of a formula. So here we are making x subject of a formula, and here we're making x subject of a formula. So now here, this is we have log base 3 of x to the power half. Okay, remember the power rule. So this is an index of square root is the power half, is equal to log base 3 of 2. Okay, now this value can be found on a calculator. Remember our rule that we stated earlier. So we can simply say, so here we can drop the power. So this is the power, or maybe before we drop the power, we can convert this to base 10. Remember, it is in base 3, unless if there is no number. If there is no number, then it is in base 10. So this is in base 3, so we can convert this to base 10 so that we can easily calculate. So this can be written as log of x to the power half divided by log of 3. So remember that conversion rule is equal to, even here we can convert this to base 10 as log the power 2, log of 2 over log of 3. Okay, now this is in base 10 and that is in base 10. If we want, we can directly calculate this on our calculator. So now from here, we can cross multiply and divide. So this will multiply with that, and basically we're going to have log of x to the power half equal to log of 2 times, so this will multiply with that, so which is times log of 3, then divide by log of 3. Okay, so simply this log of 3 and that log of 3 can cancel out, and what we're going to have is we're going to have what, x, we can say log of x to the power half is equal to log of 2. And basically here you can do one of two things. Remember, the other rule that we learned is that we can introduce logs both sides of the equation. So meaning that we can also cancel the logs if they are the same bases. We can cancel the logs from both sides. And simply this becomes x to the power half is equal to 2. We're doing that because our x is in the base. You should also consider introducing the logs both sides if x is on the power, like in the next question that I'll do. So for instance, if you have 2 to the power x is equals to 14, for instance, x is on the power, we can introduce logs both sides so that we drop the x, but here x is at the base, so we can simply get rid of the logs and remain with x is x to that, so which can simply be equal to introducing power 2 there, and x will be equal to 4. Okay, so this is the first method. The second method, we can simply go with the logs as they are. So x, we know x is 4. So, but the second method is where we consider that we can drop this power. So we drop the power. So we 1 over that log of x equal to log of 2. Okay, so this will multiply, this will be log of x equals to 2 log of 2. Okay, now you can punch this on your calculator. Log of 2 will be, so it will be about 0.3010 so times 2. So basically we can now convert from log. So this is basically, let me multiply by 2, and we have so log x is equal to 0.60205991. Now from here we can convert this this to index form. So that is another method. So in index form, we know that this is to base 10. So there is a base there. So that is base 10. So basically, you should know that if there is no number there, then it is in base 10. So this is simply 10 raised to this power. So that is 10 raised to the power 0.60205991 equal to x. And when you raise that, you're going to get, let me just raise that. So 10 raised to the power that will give us 4. So we see that we're going to have x equal to 4. Okay, so you can try it yourself. So that is how you're supposed to approach this question here. That is question A here. Okay, so that is question A. Then hope you copy that. You also go through. So make sure you go through before you can work through the question that I have given you. So try, after watching the lesson, try to work through by yourself. Then compare the answers. Then work out the problem. So now we're on this one. So that is we have 12 to the power 2x equal to 35.4. So we can drop this x by introducing logs both sides. So remember that. So we have introduced log of 12 to the power 2x is equal to log of 35.4. Okay. And basically this will drop. So it will become 2x log of 12 equal to log of 35.5, and dividing both sides, we are going to have log of 12 here and log of 12 there. Simply cancelling, then we have 2x equal to log of 35.5 divided by log of 12. Okay, which you can work out on your calculator and see how you finish it. So you can finish this one, then try B. So B for the equation that express y in terms of x. So I just want to see how you work this one out. Then I can give you more questions. All right. So for now, it's a good evening. It's a good day. Have a wonderful day. I'll see you in the next lesson.